Friends, welcome back to Pharma-info with Shubhashish. Today, the topic which I have selected, that is your nomenclature of bicyclic system, right? Okay. Now, the nomenclature of bicyclic system, usually that we get stuck, right? We get stuck while dealing with this nomenclature, especially of bicyclic system, right? Or we can say polycyclic system, because sometimes we have to come across with the polycyclic, that means more than bicyclic. Okay, we can say bicyclic is an example of a polycyclic system, but sometimes it may happen that we have to deal with a tricyclic system, right? And it carries a different way of nomenclature, right? Okay. So now today just let us see that how this can be, how we can simplify it, right? So that you can readily get to know that you can readily get in touch with the with that particular pattern and all, right? Okay. So now nomenclature of bicyclic system. Now if we just try to categorize bicyclic system, actually we have with us three, right? What are those actually? Now bicyclic system can be categorized into three different types, right? What are those? The first one is a form that is called fused bicyclic, right? Fused bicyclic, right? The second one is that is bridged bicyclic, and the third one, it's very rare, right? That is spirocyclic. Spirocyclic, right? So these are the basic, types or basic segments of bicyclic system. First one is your fused bicyclic, the second one is your bridged bicyclic, and the third one is your spirocyclic. Now we have to deal with them in a different way, right? Okay. First, let us see that if it is fused bicyclic, how it looks, what should be the morphology of that particular system. So now let us see that how it looks actually. Okay, in that case, if we just try to figure it out in this way, this is the kind of the one that is fused bicyclic system. So two cycles, 6 6. If we just try to saturate the rather if we just try to bring the unsaturation inside the ring, it is a very well-known chemical that is called naphthalene, right? And we all know that once we dealt with the chemistry of naphthalene, right? There we found that if we just keep saturating, okay, each and every bond, okay, each and every pi bond of naphthalene, it will become decalene. Decalene. So decalene is nothing but all are given the hydro term followed by naphthalene, or in other words, in a straight way, it's a decalene. So here, two carbons, they are adjacent to each other, right? That means two cycles, they are sharing a common bond, and the bond, it is the bond that means it is the two atoms, they are holding the bond, okay? Or in other words, we can say that means this is the bond which is made up of these two carbon, which is found to be common in both the cycles, and they are found to be adjacent. They are found to be adjacently placed. So this should be the criteria of what? Fused bicyclic. Okay. So this is all about your fused bicyclic. Now coming to this bridged bicyclic. Bridged. How it looks bridged. In case of bridged one, though it is a bicyclic system, but you won't find the adjacency. You won't find the adjacency of the common atoms. Adjacency of the common atoms, right? So how it looks, if we just try to figure it out, it is something like say for example, okay, right? This is the basic form. So here also two cycles, right? Now if we just try to simplify it, it is something like this. It is something like this. The same thing, no? The same thing. Here also 1, 2, 3, 4, 5, 6, 7. Here also 1, 1, 2, 3, 4, 5, 6, 7. Right? So all are found to be same. Now, so in that case, we can say both are found to be similar, right? Both are found to be similar. So here, two cycles, separated by a bridge, but here, as the bridge is made up of what? Another atom, apart from this bridgehead atoms. So that is why this portion and this portion, they are separated by a bridge. That means these two carbons, which are found to be common in both the cycles, they are non-adjacently placed. So that is why this is the feature of what? This is the feature of bridged bicyclic system. That means a bicycle in which two carbons which are found to be common in both the cycles, they are placed non-adjacent to each other, right? And as I said, that spirocyclic, the first one, we are left with the final one, that is spirocyclic. In very rare occasion you can find this one. I should not say rare occasion, because if we just try to pick the compounds from our medicinal chemistry database, okay, they are good compounds like your spironolactone, like your buspirone, right? These are the very important compounds, right? Okay, and which are holding this spiro linkage in them, right? Which are holding this, and moreover the griseofulvin. Yes, we should not ignore the contribution of griseofulvin till date. Griseofulvin is the one which is raiding the market like anything, especially the nail infection, right? Especially the nail infection which is occurring in the nail, the fungal infection which is occurring in the nail, right? Okay, so now the thing is that, so spirocyclic, though they are just they are telling that this is found to be the rarest one. Yes, though it is not found to be it is found in most of the compound, but still we have important class of compound, right? We have important class of compound which basically those compounds which are holding the spiro linkage or spirocycle in them, right? Okay, now how it looks spiro. In case of spiro, both the cycles, they are passing through a common point. What does it mean? If we just try to figure it out, how it looks, for that, if we just try to figure it out how it looks actually, as I said, two cycles, they are passing through a common point. How it looks? So let me just draw it up like this. Like this. Two cycles passing through a common point. That means here there is no bridge as such. There is no bridge, neither bridge nor two adjacently placed carbon. Instead, two cycles sharing a common atom. So this is the linkage which is called as spiro linkage, and the compound thus produced is called a spirocyclic compound. Got my point, right? So this is how we can categorize what? We can categorize bicyclic system. Bicyclic system. Fused one, bridged one, and then spirocyclic one. Example for fused, example for bridged, and example for this spirocyclic, right? Okay, now, so now let us move to the main thing, that is how they can be named. Okay, what should be the pattern we should follow? What are the rules that should be that you should abide by, right? Okay, while naming the bicyclic system, right? So what is that actually? Let us just take one after another. So let me just draw a simple compound, right? Like this. Okay. This. Okay. This. Right? This is a spiro compound actually. This one is a spiro compound. But okay, let me do one thing. This will deal later, right? Why we'll deal later? Because spiro we have kept at the last, right? So better let us bring some fused compound. Fused one is something like, okay, not fused, rather bridged one. Okay, so let us deal with the fused as well as the bridged, right? Because only difference is, in case of fused, the common atoms which are adjacently placed. In case of bridged, they are non-adjacently placed, and in between them one bridge is there. Okay, the bridge may have atom in it. Apart from this bridge and atoms and all, may not have atom in it, right? The moment you find that there is no atom as such in the bridge, that means it is an example of fused one. Why? That I am going to tell you, right? Now, so coming to this first. So what are the rules and all? First and foremost, you have to put a third parenthesis, right? you have to put a third parenthesis, right? That means you have to put a third bracket, right? In that third bracket, you have to indicate what for it is here, what for it is needed, just to mention the point. That means how many points are there, okay? As it is a bicyclic system, so this is found to be the bridgeheads, these two are found to be the bridgeheads, right? Or these two are found to be the common points, we can say. So let us just say they are found to be the common points, right? So common points means we can just give it an abbreviation called CP, common point. So here common points are found to be 2, okay, 2. So what should be the the way of writing the name of this particular compound? So first, within the parenthesis you have to mention the number. Now what should be the general feature? Like, is it comprised of 2 cycles? That means bicyclo, and then you have to mention the name of the hydrocarbon, okay? It is the name of the hydrocarbon that indicates the number of atoms that the skeleton is made up of, right? So that means how many are there? 1, 2, 3, 4, 5, 6, 7. 7 means heptane, so bicycloheptane. Now coming to this, the one that you were supposed to put in the parenthesis, in the third, bracket and all, right? Okay. So in the third, in the parenthesis, okay, what you have to put? You have to mention the number of common points. That means how many points are there in each and every, side segment. So what does it mean? Suppose key, so these two are found to be the bridgeheads or common points, right? Or CP rather, the common points. Now, if we just try to figure out this point, this bridge or this chain, right? This chain or connector, can we say that this is found to be the connector? Okay. In the process of counting the number of points which are there in each and every connector, you should not include the bridgehead. You should skip. You should ignore the CP. Okay, that means the common point. The common point should be ignored, and the rest you have to count. So how many are there? If we just consider this connector, the first connector, that means the longest chain. This is found to be the longest chain. We can say, because we don't have, see, both can be considered as the longest chain. Why? Because both are made up of 2 carbons, 2 atoms, right? So that is, both are found to be longest chain. If we just try to make it like this, then this will become the longest chain, right? But at this very moment, both are found to be the, or we can do one thing, we'll just make it like this, okay? In order to discriminate them, okay, on the basis of their priority and all, right? Because this should follow an, descending order. That means from largest to the longest to the variable, because this can vary. The bridge can be made up of a single atom, the bridge can be made up of no atom, right? That we'll see later, right? So now, for our convenience, we have just made it so as I have just extended this particular chain, so that is why I have just added another carbon. So instead of heptane, what we should call it as? We should call it as octane, right? So basically this is bicyclooctane. Now, as I said that, what should be written within the common point or within this particular parenthesis? That means you have to count the number of what? The number of points which are there in each and every chain. So this is the longest chain, this is the lowest chain, and this is found to be the variable. The variable, right? This is found to be the variable. So bridge can be considered as a variable, right? So this is longest, this is the lowest, right? Okay, a smallest, right? So this is smallest, this is largest. So how it goes? Shall we follow the ascending order or descending order? No. You have to follow what? You have to follow the descending order. That means from the highest to the lowest, and followed by the number of points that is there in the variable, right? So how it goes? That means the highest, then a complete what? A full period, which is followed by a full period, then the lowest, then the variable. The variable is nothing but the bridge. The bridge, that means the one as it is there. That is why we are just, while defining the bridged one, that means the common atoms should be non-adjacent to each other, and that is because of the presence of this bridge, right? So as I said here, highest number of points, That means this is found to be the longest chain. This is found to be the smallest chain, right? Smallest chain, and this is found to be the variable. Okay, don't get confused with this, because you may raise a question that probably say, as it is the lower one, this should be the middle one. Why? Because this is comprised of 2 and this is comprised of 1. If we just go in that direction, that means it is not found to be the right one, right? As I have mentioned, this one is the longest chain, this one is the smallest chain. We have to consider these 2 chains only. The bridge can be given as variable. The bridge can be considered as a variable, right? You can vary the bridge length and all, right? We should not consider this as a the longest chain and all, right? This is the bridge, not the chain. At present, we are just trying to discriminate the number of points which are there in either of the chains. On the basis of the number of points, we can just categorize them. We can just distinguish them. Which one is found to be the lowest, largest, and which one is found to be the smallest, right? Okay. So now accordingly, how many points are there? 1, 2, 3. So likewise, 8 should be given the number called 3. You have to put the Arabic number, no? You have to mention the number of points that each chain is comprised of. That means it is the number of points which constitute this chain, right? It is the number of points which constitute the smallest chain, and it is the number of points which constitute the bridge. Except, and in each and every category, in each and every counting, you should avoid the counting of this bridgehead, be it largest chain or the smallest chain or the bridgehead, right? Okay. So likewise, this is 3. This one is 2. So we'll just put 2 here. And what about this? The variable is 1. So likewise, if you just complete it, it is something like bicyclo. 3, 2, 1. Close the third bracket and put octane. So this is how we are done with what? We are done with the bridged bicyclic system. So this is the nomenclature which we usually follow while naming a bridged bicyclic system. And moreover, say for example, let me just keep this example or keep this structure as such here, right? Okay. Now if I put one double bond here, in that case, will there be any alteration? Will there be any alteration in the naming and all? No. Only thing is that you have to position it. Something like, and you have to start the numbering from either of the bridgehead. So this is found to be the bridgehead, okay? And from which direction it should go? It should cover the longest chain. That means we should not go to that way, rather we should follow this way. Like 1, 2, 3, 4, then 5, the another bridgehead, another terminal, right? Then 6, and then 7, and finally 8. Finally 8. So this is the feature, right? This is the feature. Okay. This is the feature which is present in this particular structure. Now, double bond is there. So that means bicyclo. What should be the naming? Bicyclo. The same system, bicyclo. Then 3 to 1. There is no change in the composition of the each and every branch, right? So it remains same only. So that is why 3 to 1. And after that, octane. But no longer it is in the form of an alkane or cycloalkane. Rather, it has become a cycloalkene. That means, as usual, the one which we are following in the naming of aliphatic system, the same thing here also it is being applied, because it is basically an example of an alicyclic system. That means aliphatic compound in a cyclic form, right? Aliphatic compound in a cyclic form, yes. Though it is not a monocyclic compound, it's a bicyclic compound. That is why there is a difference in the naming and all. In case of monocyclic compound, you don't have to put any parenthesis here. Third parenthesis has to be avoided there. No need to bring this particular information and all, right? Because there is no bridge as such. As we have kept a bridge here, that is why it came into existence, right? That means it is something like oct, then 6 in. That's all. Oct, 6 in. So now we are done with the nomenclature of what? The bridged bicyclic system. The bridged bicyclic system. Now assume that if I just want to transform this bridged bicyclic into a fused bicyclic, what I should do? Simply, fused means where the common points or the common atom should be adjacent to each other. That means only thing is that you have to remove the bridge. You have to remove the bridge which is made up of a single atom apart from the bridge heads and all. So that means just put a bond here in between them. Now it has become what? It has become what? It has become a fused bicyclic system. So in that case, what you should do? What rule should be applied here? Nothing. everything will remain same, highest, lowest and the common thing, as it is made up of no atom. Is there any atom that is there in between them? So this is an example of what? Fused. So fused do possess what? A bridge. But unfortunately, the bridge is not having any extra atom, right? And that is why you should mention that yes, the bridge is there. And how many points are there apart from these bridge heads? Only, there is no point as such. So that is why you should put here 0. And the rest of the thing is as usual. Now the one which we brought at the very beginning while dealing with the different types of this bicyclic system, there we brought an example. So the example is, now let us bring the first example, that is the one which we have written, which I wrote at the initial stage, right? That is, the example was found to be like this. This was the example, right? That time I brought. Okay. This was an example of a fused bicyclic system. That means here the common atoms or the common points are adjacent to each other. The common points are not separated by any atom, right? So this is an example of fused one. So how it goes? First and foremost, you have to count the number. On the basis of that, you have to name the cycloalkane, right? And as I said, that it is the name that indicates that the number of atoms that the whole system is comprised of, or the skeleton is made up of, right? Okay. Now, how many are there? So this is found to be the bridgehead, right? The common points. So you have to start the proceedings from either of the common point, right? And in both the chain which are comprised of the same thing, like A and B, okay? Each chain comprised of the same atoms. So in that case, you should follow like A, full stop B, or B full stop A. Either of this. Why? Because each of them comprised of same number of atoms. You cannot distinguish them on the basis of the number of atoms, as both are found to be same. Okay. So it follows like A and B. If you have considered this as A, B, so it should be like A dot P. After that, the variable. That means AB. Why I have written AB? Because as such we cannot discriminate them on the basis of the number of atoms, because both are found to be same. So there is no highest, no lowest. So that is A, then B. A means what? The number of points present in this branch. B means the number of points present in this branch. After that, the variable comprised of no atoms. So that means in the third parenthesis or third bracket, what you should put here? How many are there? 1, 2, 3, 4. So 4 dot 1, 2, 3, 4. Again 4. Then what about this? No atom. No atom means 0. No atom means 0. Now, what should be prefixed here and what should be suffixed here? The prefix should be bicyclo. The suffix is the name of the cycloalkane. So how many number of atoms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 are there. That means decane. So bicyclodecane. If there is any double bond, mention the position of the double bond, right? Mention the position of the double bond. If substituent is there, suppose if substituent is there, okay, chalo. If substituent is there at this position, suppose the substituent is found to be methyl. That means before putting this bicyclo, you have to put the name and the position of the substituent. That means it is 1. We have to start the locate number which has to be given the bridgehead. That means we have to start the proceedings from here. 1, 2. So 2. So first it is 2-methyl bicyclo 4,4,0 decane. Right? So this is how the bicyclic system, that means the fused at the same time, the bridged bicyclic system are named. We have ample number of examples. Let us deal with that. Okay. So till now we have seen the way by which bicyclic systems are named. But what are the examples that we brought during this discussion, right? Basically is of they are of hydrocarbons, right? But we have not mentioned that what happens when a bicyclic system comprised of a heteroatom. Is there any additional rule that should be implemented, right, while naming or while go for naming and all? Okay, that we'll see. Definitely we'll see that one. Whether any additional rules has to be implemented or not. And along with that, we have to bring, and we'll bring a few examples and all, few applications and all. Some compounds which are found to be bioactive in nature. We'll bring into your notice and all, so that we can get to know about, at least we can, make our understanding even better, right, with all those examples and all. So with all these things, I'll come in my next video. So till then, thank you.